Okay, so you are once again welcome to my channel. We have a question here that we are going to be solving today. Okay, so it says two resistors are connected in series across a 24 volts supply and a current of 3 amps flows in the circuit. If one of the resistors has a resistance of 2 ohms, determine A, the value of the other resistor, and then B, the PD across the 2 ohm resistor. If the circuit is connected for 50 hours, how much energy will be used? So before we start with the solution, please subscribe to the channel. Okay, all right, so this is how the circuit is going to be. We have two resistors, resistor R1 and then resistor RX in series. The value for R1 is 2 ohms and then RX is an unknown resistor, so we will calculate for the value for RX. Then we have our I, which is the total current, and it's 3 amps. Then we have the total voltage across the circuit, which is 24 volts. And then the PD across the resistor R1, that is also unknown, so we'll be calculating that also. Okay, so let's move on with the solution. So we have our diagram once again. R1 is 2 ohms, RX we don't know. Then we have our current, which is 3 amps. Then the total voltage across the circuit, which is 24 volts. Then the PD across R1, which is also unknown. Question A says we should calculate for the unknown resistor. Okay, that is RX. But before we calculate for RX, we first of all have to calculate for the total resistance. Okay, so solution A. By Ohm's law, we know that R equals V over I. Okay, that is resistance is equal to the voltage over current. Okay, that is R equals V over I. So our V is 24 divided by our I, which is 3. So when you divide 24 by 3, we'll be getting what? 8 ohms. So the total resistance of the circuit is 8 ohms. So now that we have the total resistance of the circuit, to calculate for the unknown resistor, which is RX, we just subtract R1 from the total resistance to get our RX. I hope you are following. So the value for the unknown resistance, RX, is equal to 8, which is the total resistance, minus 2, which is R1, which will give us what? 6 ohms. So our RX, which is the unknown resistance, is equal to 6 ohms. Okay, so let's move on to solution B, which says we should calculate for the PD across the 2 ohm resistor. Okay, all right. So by Ohm's law, V equals I, which is the total current, times R, which is the resistance. So since we are calculating for V1, which is the PD across the 2 ohm resistor, which is resistor R1, we say V1 equals I, which is the total current, times R1. Okay, so we have our I, which is 3, and then our R1, which is 2. So when you multiply 3 by 2, we are going to get what? 6 volts. So the PD across the 2 ohm resistor, which is resistor R1, is 6 volts. So the energy used is also equals the power times time. Okay, how do we calculate for power? Power can be calculated by multiplying the total voltage by the total current. Okay, total voltage by the total current to get power. Okay, so we have the total voltage, which is 24, times the total current, which is 3 in watts, because the moment you multiply the total voltage by the current, you are calculating for power. So 24 by 3 in watts times our time, which is 50 hours. Okay, so when you multiply 24 times 3 times 50, we are going to get 3,600 watt hours. So to convert this into kilowatt hour, we are going to get 3.6 kilowatt hour. So I thank you so much, and please make sure you subscribe to the channel. Thank you.